Hello and welcome back to my YouTube series on the evidence for evolution. If this is your first time visiting my channel, please let me introduce myself. My name is Tony B. I am a multi-instrumentalist singer-songwriter. Yes, I'm a musician with an interest in the correct education of science. As such, I have attempted to create videos that provide information and which present evidence that challenges misinformation and dishonest narrative from some young earth creationists who wish to deny any science that might challenge a biblical perspective. Please take time to view my other videos on YouTube on the science of evolution. This video continues the section of my collection that looks at the evidence for deep time. In this episode, we are going to look at how scientists date fossils, the use of carbon-14 dating. And yes, carbon dating does not prove an Earth that is millions of years of age, but it does prove an Earth that is over 6,000 years of age, as believed by young Earth creationists, and as such contributes to the evidence of deep time. The point of this particular video is not to prove the Earth is 4 billion years of age. I have other videos that prove that point. This video is about proving the Earth is more than the 6,000 year age proposed by the creationist model. The carbon-14 dating process is effective up to 50,000 years. It therefore proves the Earth is more than 6,000 years old. It disproves the creation model and adds, I say adds, to the evidence of deep time. Now, it is important for you to know that carbon-14 dating methods only work on dead organisms. I say this as some creationists, such as Ken Hovind, does not appear to realise this fact. And what is worrying is that he sells his videos on carbon dating to his followers who I fear are being given misinformation. Please watch this clip of film of Ken Hovind, one of the most vocal creationists on YouTube. This is part of a debate he completed with the late, great Bill Ludlow.
Well, then why would you use a freshly killed seal and a live animal as evidence that the method doesn't work?
Why would a live animal...
And presenting a straw man or not?
No, Bill, why would a live animal give a wrong date? And if a live animal gives a wrong date...
Listen, you don't understand the method at all.
I do indeed.
No, you don't. If you just ask why a live animal would give a wrong date, you don't understand the method. The method, when the animal dies, Kent, it starts to deteriorate, carbon-14 to carbon-12. We can't, there's no way you could get an accurate method, a measurement from a live animal. No way. Well, if you don't understand that, you shouldn't even be talking about it. Right there. That one, X. That one, X. Okay?
I understand it very well. Now, if you want to change this topic of the debate to carbon dating, we can do that. But as far as human evolution, if modern humans were carbon dated, if you and I were carbon dated, would we give the same carbon date? We're both living in the same atmosphere, eating the same food. Why wouldn't it work for living? You showed us
work for living because we aren't dead yet. We're still in equilibrium with the environment.
Okay, then we should give the same.
You don't understand this at all.
I do. Bill, wake up. We should give the same date. We're both in the same environment. We're living, breathing the same air and eating the same food. Yes, we should give the same date, but we won't.
There's no date to give until you've been dead for at least 100 years, Kent.
Think about how silly that is, what you just said. There's no date. It should work on anything. How would you know?
It doesn't work on anything. It works on things that are between 100 years old, dead, 100 years dead, and 50,000 years dead. Okay? It doesn't work on alive.
Think about it. It should.
Can you explain? As you can see in that clip, the creationist Ken Hovind does not understand science. Carbon dating only works when carbon-14 atoms start to decay. This means the once living organism being tested has to be dead. Why? Well, because living organisms constantly exchange carbon atoms with the atmosphere and other organisms, keeping their carbon-14-12 ratio constant. Therefore, the sample has to be dead. Poor Kent. I am going to assume you all have a basic understanding of carbon and nitrogen cycles on Earth, photosynthesis, and what atoms and isotopes are. But do not worry, we will review this in the video. That said, let us look at carbon-14. Carbon-14 is constantly being created in the atmosphere by the interaction of cosmic rays with atmospheric nitrogen. Cosmic rays are high-energy protons and atomic nuclei that move through space at nearly the speed of light. They originate from the Sun, from outside the solar system of our galaxy, and from distant galaxies. Cosmic rays ionize the nitrogen and oxygen molecules in the atmosphere. Ionization is the process by which an atom or a molecule acquires a negative or positive charge by gaining or losing electrons. This leads to chemical reactions which are responsible for the continuous production of a number of unstable isotopes such as carbon-14. What this means is that the cosmic rays knock neutrons off some atoms and protons off others. Nitrogen-14 loses one proton and gains one neutron and becomes carbon-14. Carbon-14 atoms are radioactive and unstable, and we know that they are formed at a reliable, steady rate. Carbon-12 atoms are also in the atmosphere, and they are stable. So, at any point in time, we are aware of the ratio of carbon-12 and carbon-14 atoms. The ratio of carbon-12 and carbon-14 found in all living things on Earth is about the same as in the atmosphere, which means it is predictable. It was an American physical chemist named Willard Libby who in 1949 developed the process of radiocarbon dating. In 1939, Serge Koeff discovered that cosmic rays generated neutrons in the upper atmosphere. He discovered that cosmic rays in the air interact with nitrogen-14 to produce carbon-14. This led to Willard Libby realizing that when plants and animals die, they cease to ingest fresh carbon-14. Therefore, it was Libby's conclusion that any organic compound has a built-in nuclear clock. Libby looked at the principles that during its life, a plant or animal is in equilibrium with its surroundings by exchanging carbon either with the atmosphere or through its diet. It will therefore have the same proportion of carbon-14 as the atmosphere. Once it dies, it ceases to acquire carbon-14, but the carbon-14 within its biological material at that time will continue to decay. So the ratio of carbon-14 to carbon-12 in the remains will gradually decrease. Scientists needed to test this theory. Tests against sequoia trees with known dates from their rings demonstrated that radiocarbon dating is reliable and accurate. In 1960, Libby was awarded the Nobel Prize in Chemistry for his method to use carbon-14 for age determination in archaeology, geology, geophysics, and other branches of science. So, as a simple review, carbon-14, cosmic rays, and oxygen in the atmosphere create carbon dioxide. Plants absorb carbon dioxide. Animals then eat the plants, and some animals, such as humans, will eat other animals. Therefore, the ratio of normal carbon-12 to carbon-14 in the air and in all living things at any given time is nearly always constant. Carbon-14 atoms are always decaying, but they are being replaced by new carbon-14 atoms at a constant rate. As already stated, as soon as a living organism dies, it stops taking in new carbon. The ratio of carbon-12 to carbon-14 at the moment of death is the same as every other living thing, but the carbon-14 decays and is not replaced. Scientists have demonstrated that the unstable carbon-14 atoms decay with a half-life of 5,700 years, while the amount of stable carbon-12 atoms remain constant. By looking at the ratio of carbon-12 to carbon-14 atoms in a sample of a dead organism and comparing this sample to the ratio in a current living organism, it is possible to determine the age of a former living organism. As stated, plants absorb the carbon. Plants are eaten by animals. Animals eat animals. Every plant and animal in this chain will therefore have the same amount of carbon-14 compared to the carbon-12 in the atmosphere. This is called the carbon-14 carbon-12 ratio. Scientists analyze the radioactive decay of carbon-14 atoms to determine the age of a fossil because the radioactive decay is used as a clock. It is unaffected by physical and chemical conditions, by temperature and water. Scientists will look at the ratio of carbon-12 and carbon-14 atoms in the sample. Remember, there is a steady rate of decay and the half-life is 5,700 years. So, as stated, as soon as a living organism dies, it stops taking in new carbon. The ratio of carbon-12 to carbon-14 at the moment of death is the same as every other living thing, but the carbon-14 decays and is not replaced. The carbon-14 decays with its half-life of 5,700 years, while the amount of carbon-12 remains constant in the sample. By looking at the ratio of carbon-12 to carbon-14 in the sample and comparing it to the ratio in a living organism, it is possible to determine the age of a formerly living thing fairly precisely. This is the formula used to calculate how old a sample is by carbon-14 dating. Remember, the half-life is 5,700 years. So, if you had a fossil that had 10% carbon-14 compared to a living sample, then that fossil's age would be calculated using the following formula. Because the half-life of carbon-14 is 5,700 years, it is only reliable for dating objects up to about 50,000 years. However, the principle of carbon-14 dating applies to other isotopes as well. Potassium-40 is another radioactive element naturally found in your body and has a half-life of 1.3 billion years. Other useful radioisotopes for radioactive dating include uranium-235 with a half-life of 704 million years, uranium-238 with a half-life of 4.5 billion years, thorium-232, a half-life of 14 billion years, and rubidium-87, a half-life of 49 billion years. The use of various radioisotopes allows the dating of biological and geological samples with a high degree of accuracy. Scientists do not just use pen and paper and theories. They also use machines to help them calculate the equations presented and support the process employed. Such machines include an accelerator mass spectrometer and a liquid scintillation counter. There are three principal techniques used to measure carbon content of any given sample: gas proportional counting, liquid scintillation counting, and accelerator mass spectrometry. Due to some mistakes that have been made, young Earth creationists will state that carbon-14 dating cannot be trusted, and therefore it cannot prove the Earth is more than 6,000 years of age. Let us now look at the issues for carbon-14 dating and how they have been solved. When conducting a carbon-14 test, there might be considerations to take into account. For example, a variation in the carbon-14 to carbon-12 ratio in the atmosphere, both geographically and over time. Isotopic fractionation, variations in the carbon-14 and carbon-12 ratio in different parts of the reservoir, and contamination of samples. Coal and oil burnt in large quantities during the 19th century and had an impact. As materials, they were so old that they contained little or no detectable carbon-14. As a result, the carbon dioxide released substantially diluted the atmospheric carbon-14 carbon-12 ratio. Hence, dating an object from the early 20th century gives an apparent date older than the true date. In the 1950s and 1960s, above-ground nuclear testing released large numbers of neutrons into the atmosphere, resulting in the creation of carbon-14. From 1950 until 1963, it was estimated that several tons of carbon-14 were created. This doubled the amount of carbon-14 in the atmosphere. This peaked in the Northern Hemisphere in 1964 and in the Southern Hemisphere in 1966. Since then, the level has dropped. In isotopic fractionation, carbon-12 absorbs slightly more easily than carbon-13 in photosynthesis, and in turn more easily than carbon-14. The differential uptake of three carbon isotopes, carbon-12, 13 and 14 ratios in plants differ from the ratios in the atmosphere. This is known as isotopic fractionation. To counter this, scientists have to determine the degree of fractionation in a given plant sample. The amount of both carbon-12 and carbon-13 isotopes are measured, and the resulting carbon-12 and 13 ratio is compared to a standard ratio. The carbon-12 to 13 ratio is used instead of the 12 to 14 because the former 12 to 13 is much easier to measure. Therefore, the latter, the carbon-12 to carbon-14 ratio, can be easily derived. The depletion of carbon-13 relative to carbon-12 is proportional to the difference in the atomic masses of the two isotopes. So, the depletion of carbon-14 is twice the depletion of carbon-13. Calculations for marine photosynthetic organisms are dependent on temperature. At the highest temperature, carbon dioxide has poor solubility in water, which means there is less carbon dioxide available for the photosynthetic reactions. Under these conditions, fractionation is reduced, and at temperatures above 14C, the carbon-13 values are correspondingly higher, while at lower temperatures, carbon dioxide becomes more soluble and hence more available to marine organisms. There is also something called the reservoir effect. The mixing of deep and surface waters takes far longer than the mixing of atmospheric CO2 with the surface waters, and as a result, water from some deep ocean areas have an apparent radiocarbon age of several thousand years. Upwelling mixes this old water with the surface water, giving the surface water an apparent age of about several hundred years after correcting for fractionation. Northern and southern hemispheres have atmospheric circulation systems that are sufficiently independent of each other that there is a noticeable time lag in mixing between the two. Because the greater surface area of ocean in the southern hemisphere means that there is more carbon exchange between the oceans and the atmosphere than in the north, since the surface ocean is depleted in carbon-14 because of the marine effect, carbon-14 is removed from the southern atmosphere more quickly than in the south. In respect of other effects that can affect dating, if the carbon in fresh water is partly acquired from aged carbon in rocks such as limestone, then the result will be a reduction in the carbon-14:12 ratio in the water. For example, rivers that pass over limestone, which is mostly composed of calcium carbonate, will acquire carbonate. Similarly, groundwater can contain carbon derived from the rocks through which it has passed. These rocks are usually so old that they no longer contain any measurable carbon-14, so this carbon lowers the carbon-14:12 ratio of the water it enters, which can lead to apparent ages of thousands of years for both the affected water and the plants and freshwater organisms that live in it. To determine age, steps are taken to compare the radiocarbon age of deposited freshwater shells with associated organic material. Volcanic eruptions eject large amounts of carbon into the air. The carbon has no detectable carbon-14, so the 14:12 ratio in the vicinity of the volcano is depressed relative to the surrounding areas of plants that photosynthesize. Contamination with modern carbon causes a sample to be younger than it really is. For example, if a sample that is 34,000 years old is contaminated by 1% of modern carbon, it will cause an error of 4,000 years. Contamination with older carbon has the opposite effect. So, what's important to remember is that the scientists understand. They are aware that mistakes have been made in the past due to these issues. Therefore, they take precautions to counter these obstacles, to ensure that these issues are taken into account when dating samples. Therefore, what can scientists do to reduce the margin of error when using carbon-14 dating methods? Well, one of the first steps to take is to convert samples to be tested into a form suitable for measuring carbon-14 content. Scientists convert samples to gaseous, liquid, or solid form. Samples are treated to remove contamination. Any unwanted constituents are removed. Alkali and acid washes can be used to remove humic acid and carbonate contamination. As already stated, scientists are aware of the four major considerations to take into account when using carbon-14 dating methods, such as variations in the carbon-14 and 12 ratio in the atmosphere, both geographically and over time, isotopic fractionation, variations in the carbon-14:12 ratio in different parts of the reservoir, and contamination. Therefore, looking at these possible problems, knowing that they exist, taking them into account, and then ensuring proper preparation of samples and the application of dating methods to obtain accurate dating up to 50,000 years is ensured. Scientists will use machines such as the accelerator mass spectrum to help obtain correct carbon dating of samples. The liquid scintillation spectrometer counts the number of decays occurring per minute. Computers then analyze the data. As we can see, atmospheric carbon-14 to 12 ratios have not been constant historically. Due to the fact the atmospheric carbon-14 and 12 ratio has not been constant historically, scientists developed a process called radiocarbon calibration, in which radiocarbon years are converted to calendar years. To produce a curve that can be used to relate calendar years to radiocarbon years, a sequence of securely dated samples is needed which can be tested to determine their age. The study of tree rings led to the first such sequence. More recently, the IntCal series of curves, including data from tree rings, varves, coral and other studies, have helped to establish calibration curves to convert from radiocarbon years to calendar years. The IntCal 13 data includes separate curves for the northern and southern hemisphere, as they differ systematically because of the hemisphere effect. There is also a separate marine calibration curve, all of which helps us to home into more accurate dates that support the carbon-14 dating process. To date an object, researchers use mass spectrometers or other instruments to determine the ratio of carbon-14 and 12. The results are then calibrated and presented along with a margin of error. Modern statistical methods and updated databases allow scientists to take human effects on the Earth's atmosphere into account. If you possess a grain of common sense and intelligence, then I am sure you will agree that this video has illustrated radiocarbon dating as one of the most reliable of all radiometric dating methods, and that it proves young Earth creationism wrong in their assertion that the Earth is only 6,000 years of age. In fact, the oldest samples dated by carbon-14 is the flutes from the Geisenkostel cave. Carbon dating show they are between 42,000 to 43,000 years, a lot older than the 6,000-year Earth proposed by young Earth creationists. Despite the evidence, creationists will continue to make claims that are being continually refuted by the science. Remember, young Earth creationists start their argument with a belief in the Bible. This is their starting point. They are not led by the science. They are led by the Bible. They will only accept science if it fits with their belief. They will reject it if it challenges their belief. And carbon-14 dating challenges a 6,000-year-old Earth. Among their claims that carbon dating does not prove an Earth older than 6,000 years is that some coal, oil and natural gas contain measurable amounts of carbon-14. How can this be so if a sample older than 50,000 years should not have any measurable carbon-14? Material older than 20,000 years have so little carbon-14 left that their beta radiation is swamped out. It is swamped out by the background radiation of cosmic rays and potassium-40 decay. Anything beyond 50,000 years cannot be measured as there is no carbon content left. In older organic samples, the beta radiation has to be compensated for. The amount of carbon-14 they have left is less than the margin of error in measuring background radiation. Cosmic rays form beta radiation all the time. This is the radiation that turns nitrogen-14 to carbon-14. Potassium-40, known as K40, also forms plenty of beta radiation. This isotope, K40, accounts for a large part of the normal background radiation that can be detected on the Earth's surface. This radiation cannot be totally eliminated from the lab, so one could probably get a radiocarbon date of 50,000 years from a pure carbon-free piece of tin. Remember the four main problems we looked at relating to dating objects? Well, another attempt creationists make to discredit carbon-14 dating is to state that freshwater organisms give incorrect radiocarbon dates. What they do not tell you is that scientists are aware of the limestone that freshwater passes over and which is mostly composed of calcium carbonate. These rocks are usually so old that they no longer contain any measurable carbon-14. So this lowers the carbon-14-12 ratio of the water it enters and can affect the plants and freshwater organisms that live in it. But trust me, scientists are aware of this fact and appropriate measures are taken to ensure correct dating. And one last thing to add to the data in respect of creationists trying to discredit carbon-14 dating. The decay of uranium and thorium underground produces radiation which can create carbon-14 from carbon-12. Scientists are aware of this. This is known as cluster decay, where a given isotope emits a particle heavier than an alpha particle. And yet, despite creationists trying to discredit the process, they accept the carbon-14 dating of the Dead Sea Scrolls. Double standards? Maybe. But as we noted in the clip of film of Kent Hovind at the start of this presentation, do not trust a creationist perspective of carbon-14 dating, as many do not understand it. This was evident in the statements made by Kent Hovind. The fact is, carbon dating supports the evidence that our planet is older than 6,000 years, and is another piece of evidence that supports deep time, which in turn supports the science of evolution. Thank you for watching this video. I look forward to your feedback and I hope you take the time to view other videos in this series of the science of evolution. Goodbye for now.